This is X3 practice exams, questions 4 to 8. So they're kind of natural language related questions plus some basic network questions. So the first one is asking about the probability of observing a new sentence given the Unigram model. So it will be a lot easier to do a Unigram model where everything is assumed to be independent compared to a bigram model, because when you use bigram you need to like count the number of times one word is followed by another. So here it's a simple case where you just compute the probability of each word happening. So the probability of I is it occurred once in a training data of 5 words, and the probability of Groot, it appeared twice in a data set of size 5. So we have these two probabilities, and given the first word is already I, so we do not compute that probability. We want to compute the probability of basically I given I and Groot given I. And being a Unigram model means these given, so it's not important. If we are talking about bigram model, then we get rid of that I. If we are talking about trigram model, we need like all of the conditional probabilities. But again, here it's Unigram, so it's just probability of I times probability of Groot. We have these two, so the answer is just 3/25. And we're not doing smoothing, so just multiply these two. Okay, so the next one, we are estimating the conditional probability of a network, a Bayesian network like this. So it looks like AC pointing to B. And the question is asking about B given A, not B given AC. So that's basically just counting B is 0, A is C, A is 1 and C is 1, divided by the count of just A is 1 and C is 1. And we need to do Laplace smoothing, so we need to add 1 on the top, and on the bottom we just add the number of possible values of B, which is 2. Okay, so let's just count stuff. A is 1 and C is 1, let's see. A is 1 and C is 1. And that there are 2 of these, and among them B is always 0. So on the top is 2 plus 1, on the bottom is 2 plus 2. So at the end it's 3/4. Alright, so let's continue. We have this A, B, C network. And A can take 4 values, B can take 3 values, C can take 4 values again. Excuse me. And we want to find the number of conditional probabilities that we need to store. So the idea is very similar to an earlier question that I talked about in this practice exam. It's basically, if we want A is say 4, it's just A, probability of A is 2 minus probability of A is 1, and probability of A is 2, and A is 3. So for A, you just need to store 3 variables. I think the same thing happens with B. So probability of B being 3, B depends on A. So B given A is 1 can be written as just 1 minus B is 1 given A is 1 minus B is 2 given A is 1. So you only need to store 2 for each A, and there are 4 A's, so there are 8 in total. So far we have stored 3 variables for A, and for each A we need to store 2 numbers for B, and you can see the pattern. C based on B, you want the C given B variables, and there are 4 values of C, so you need to store 3 of them. The other one can be computed by 1 minus the rest. And you have 3 possible values of B, and for each one you need to store 3 values of C. So that's the total number of probabilities you need to store. Okay. So excuse me. So the next question is basically the same, except for you need to draw the naive Bayes diagram. So let's do it. And you should probably remember the direction. So it's everything based on y. So naive Bayes is kind of a generative model. So given y, you can generate the axis. So it goes this way. We have x1, x2, x3, x4, and all of them are conditioned on y. So for y, you need to store probability of y is, again, there are 3 classes, so y is 3 can be computed as 1 minus y is 1 and y is 2. So for y, you need to store 2. And for x1, there are 6 possible values, and 6 possible values means to find the probability of x1 is 6 given a fixed y, you can do 1 minus x is 1, x is 2, x is 4, and 3, 4, and 5. So for x1, there are 3 classes, and for each class, you need to store 5 numbers, because the 6th number can be computed based on these 5. And that's only for x1. And there are 4 of them, so multiply it by another 4. So that's the total number of values you need to store. Again, given a naive Bayes network, you need to first draw the network, and then y is kind of independent of the other ones. So you just need to store the prior probability of y, and there are 3 classes, so you need to store 2, and for each of these, for each class of y, you need to store 5 numbers, and you can figure out the 6. So basically, for each x, you store 15, and there are 4 x's. So that's the total number. Okay, so the last question is question 8. It's kind of independent from the other ones because it's the CDF inversion, or in class I also call it inverse transform method, but they mean the same thing. Basically, we look at, initially it's I, so let's maybe draw this. I am Groot, and I am Groot. So you need to first be able to read this transition matrix, and this 0.2 means starting from an I, the probability of the next one being M is 0.2. So basically, starting from I, the probability distribution is this after an I. And the next one is I with probability 0.38, and the next one is M with probability 0.2, and so on. So one way to do this is draw the number line, and this is 0.38, this 0.2, 0.442, and then you pick a random number that's 0.42, it's basically somewhere here. It's a bit larger than 0.38, but it's not larger, I mean less than 0.58. So 0.42 is here. So, and here it represents M. So the second word is M. And you are asked to enter the label, so the next number is 1. Okay, so now you are starting with M. So the distribution for the next word would be 0.33, 0.37, and 0.3. So that's starting with an M. And you can do exactly the same thing, drawing the number line and figure out where the number is, or you can compute a CDF. So the CDF is just the cumulative sum of these numbers, 0.33, 0.7, and 1. And we're at 0.5, so 0.5 is somewhere in between here, so that you can invert this and get the index, which is 1. So the next one is still an M, and you can enter label 1 for M.